Welcome to the presentation. Like I mentioned, my name is Evert-Jan Blom and I'm the owner of Genetic Affairs. Well, after this excellent talk by Alec, I will now give a presentation about 4 of the tools from my website. If all went well, I've just pasted a handout of my presentation at chat, but I might have sent that directly to somebody. Maybe Tim, you can check if it's in the to everyone section. Genetic Affairs. This is the outline of the complete presentation. We'll first discuss it's actually partitioned into 5 parts. We'll first discuss the AutoCluster tool, which can be used to cluster your DNA matches based on shared matches. Next, another tool which might be quite relevant because of the excellent talk of Alec about the whole segment-based analysis, or the AutoSegment. In the third part of the presentation, I will be reviewing the AutoTree tool, which is used to find common ancestors in trees that are shared by DNA matches. And our last tool is AutoKinship, which can create trees based on shared DNA between DNA matches. And so this doesn't require trees from matches. It only needs the shared DNA between DNA matches. And finally, I always like to present something new in every presentation. I'm releasing some details about the new upcoming AutoKinship implementation, which is now being developed and tested on GEDmatch. So that's the newest development. So let's start with the AutoCluster. This is the outline of the AutoCluster part of the presentation. We'll first discuss why the AutoCluster can help your genetic genealogy research. Next, how the AutoCluster works, and then it's followed by the visualization and concept. We also touch upon the ordering of clusters and show you how you can start the clustering for the different DNA testing companies. And every part ends with a small conclusion. So the methodology of clustering is all based on the idea that you can break your entire DNA match list into groups if you wanted to. And if you wanted to, if your family members aren't related to each other, you can break up your match list into 4 groups. These groups would represent your great-grandparent couples. You could, if you wanted to, and break up your entire DNA match list into 8 groups that represent your 2 times great-grandparent couples. And you can even expand that further. So this is the central concept of clustering. So you aren't looking at your matches, how they are related to you. You're looking to first group your matches into clusters and then investigate each cluster. So what can we do with those clusters? So why would one like to use a cluster instead of a DNA match list? Well, these clusters provide hypotheses about the shared common ancestry. As we discussed in the previous slides, some members of the clusters are likely to share the same common ancestor and represent a branch of your family. So instead of looking at each match individually, we now look at the cluster and create hypotheses for the members of that particular cluster. So the analysis of the cluster typically involves looking at the trees of matches from a cluster, trying to find the common ancestors, link them with your own ancestors, or if you're an adoptee, you try to find common ancestors between the trees of the matches from a single cluster. If the trees are not readily available for a match, you can check for common surnames, locations in the trees of the matches that are available. How does the tool work? So like I said, the clustering is a process where you organize an unorganized list of DNA matches to groups of related matches. So for instance, at the left side, we have our family tree DNA match list, which is ordered based on the genetic relatedness for every match. So your top matches are in the top section. To cluster these data, we first examine all matches of interest. So we take this DNA match list and for every single match, find its shared matches. We thereby construct a genetic network. And we use this network to identify groups or clusters or linked matches. Now we have the DNA matches that are grouped together. And these groups are called clusters. The AutoCluster tool performs this analysis automatically and thereby organizes your matches in those shared match clusters. And based on these clusters, it then provides a visual chart. It starts out unsorted like this, and then it organizes itself into the clusters. Okay, now let's discuss some of the concepts of the AutoCluster chart. The top section of the chart contains confirmation concerning the analysis, like the person or profile that got tested, the DNA testing company, and the date of the analysis. The order by selection allows you to reorder your DNA matches, but in most cases, the cluster ordering will be the most appropriate. For the animation, it starts out with the name ordering, and then it quickly transforms into the cluster order. The right side of the chart will have some information concerning the clusters and the number of matches within each cluster. Now let's focus on the DNA match visualization in the chart. The matrix you're seeing is actually symmetrical. So every DNA match on the x-axis is also available on the y-axis. Your DNA matches are listed on both axes. For instance, you match Vanilla Pamplin and Elke Hegna. However, Vanilla and Elke match each other as well. So for Vanilla, we have Elke in the shared matches and vice versa. You, the tested person, match Theo Williams. However, Vanilla does not match Theo. Still, they are in the same cluster. It's not necessary for matches to match all other matches in a cluster. That would otherwise be quite too restrictive. Clusters can be filled completely, meaning that they match every member in the cluster, but it's not a requirement. You can also see some gray cells in the chart, and as was indicated in the previous presentation, that can be quite an indication of endogamy. But in some cases, the gray cells can also link clusters, can indicate a relationship between those clusters. For instance, match Elke Hegna could be a high centimorgan match that links two branches of your family. Elke Hegna matches quite a few matches in the green cluster, so she could have been a member of that cluster as well. However, since she matches even more members in the orange cluster, the algorithm has placed her in the orange cluster. She could have been, for instance, a maternal second cousin, and the orange cluster could be a maternal branch, while the maternal branch of your family is linked to the green cluster. Elke is a maternal match and therefore is a member of both groups. In other cases, there are empty cells in your clustering. For instance, Vanilla that does not match 4 matches in the cluster. It's good to remember that based on chance, you sometimes not always match with a genealogical match. For instance, there's a 31% chance that you're not sharing any DNA with the 4th cousin. Or it could be that the shared centimorgan threshold is too high. If the minimum is set to 20 and the match sharing is sharing 50 centimorgans, it will not be considered a shared match. The initial sorting of the clusters was based on the cluster size. And as you can see in the chart, cluster 1 is the largest cluster and the following clusters get smaller and smaller. I think this is still the default clustering order at the MyHeritage. However, a more intuitive way of sorting would be to employ the gray cells, since that can be indicative for certain interactions between the clusters. If you would sort the clusters based on the links between them, we should link cluster 5 with 1 and link cluster 4 with 2. These connected clusters are often nicely correlating with branches from your ancestry tree. So on the top left, we might have a paternal cluster, followed by a paternal cluster in red. Next to it is a paternal cluster. So usually, as discussed before, these clusters are linked by high centimorgan matches, which can be a member of multiple clusters. The clustering of these clusters can then also give rise to so-called superclusters, which are groups of clusters that are closely related to each other. Underneath the AutoCluster chart is information about the analysis, the settings, and other information, and a table is provided that contains the matches for each cluster. This table contains a link to the DNA match, shared DNA, notes, link to a tree if available, etc. I will now quickly show how to start an analysis on the website. And this is now being shown for the AutoCluster tool, but it's more or less the same for the other tools as well. So after a user has registered on a members page, you will be redirected to the main page with several options. For instance, it shows you websites and allows you to register even more websites and start various analysis. For instance, the AutoCluster analysis. To start the analysis, you first register an account from Family Tree DNA or 23andMe. Next, you select the profile of interest by clicking on the Profiles button for that account, set the parameters, the maximum and minimum shared amount of centimorgans, the minimum shared segment size, and as indicated in the previous presentation, which can be quite significant. And for 23andMe, how much DNA matches should share with each other. Once everything is set, start the analysis. In addition to the shared centimorgan data between shared matches, so how much DNA a shared match is sharing with the other shared matches, 23andMe also provides the label shared DNA for your shared matches, or as 23andMe calls them, relatives in common. Here we see the DNA matches I have in common with a certain match. The last column shows if there's a shared DNA. If you click on the yes, you will be redirected to the chromosome browser which then shows you the segments that are overlapping. If these are the only segments that are overlapping, you can be fairly certain that these are triangulating. To visualize these shared DNA matches, a DNA match helix is added to the visualization of the chart. So here you see a cluster containing some of these helixes, and other ones are not present, so that's a regular shared match. It's good to realize that the default clustering occurs using the shared matches, but it's also possible to run the analysis using only matches with shared segments, and then you get clusters that only have the helix symbols in it. So everything is filled with the helix symbol. In addition, it's even possible to perform the clustering solely on triangulating segments. And this method is discussed in the next part of the presentation, where we'll discuss the AutoSegment tool. So let's see a comparison for the AutoCluster analysis for 23andMe using the default 5 centimorgan setting. So at 23andMe, they consider a shared match if they share 5 centimorgans or more. As you can see, there are quite a few gray cells, and the clusters are not that distinct. If you raise the value, so the minimum shared centimorgan between shared matches, to 10 centimorgan, the clusters become much more defined. Note that for ancestry, this number is even higher and set to 20 centimorgan. And that's one of the reasons why clusters based on ancestry data are usually quite distinct. It's also possible to perform clustering analysis for other DNA testing companies like Ancestry or Living DNA. But for this purpose, we need to manually obtain the matches and shared match data. So this can be accomplished by entering this information to a spreadsheet and save the 2 sheets to CSV files. The first sheet should contain the DNA matches and will hold 3 columns. The first column, the name, the second, the centimorgans, and the third one, the nodes. The second sheet in the spreadsheet contains the shared match information, consists of 2 columns. The first column contains the match, whereas the second column has the shared match. Next, you select the AutoCluster using the CSV files option on the members page. You adjust the settings, provide a name, select the 2 files, and you start the analysis. Results are typically emailed with an attachment. However, in some cases, the emails are not arriving, or the large attachments are too large and will not be attached. Instead, they are provided as a download link, and then it is possible to download the analysis from our service. To download the analysis from our service, you go to the member site, you click on the notifications in the top right section. After clicking on the bell, you will see the list of notifications, and each notification will contain a link to an update or direct download link. If you click on it, you can get the zip file, you unzip it, you open the HTML, and you will be redirected to the results. The implementation on MyHeritage. So let's discuss some of the other AutoCluster implementations. The AutoCluster algorithm was licensed to MyHeritage in the beginning of 2019, and for this implementation, a special version of the tool was used. This version first examines various ranges of centimorgan settings using the shared centimorgans between matches as well. To provide a consistent visualization, the AutoCluster analysis contained around 100 matches, and that is provided to users. Employing the shared centimorgan setting between DNA matches helps a bit to provide clusters for people from endogamous populations as well. So to put it a bit into perspective, the tool will benchmark a whole range of different settings. And typically for people from endogamous groups, will then have a higher setting, so a higher value for the number of shared centimorgans between shared matches. That can then give rise to a certain amount of clusters, although the added value is limited. Because as mentioned before in the other presentation, clustering using shared matches is not that useful for people from endogamous groups. The AutoCluster algorithm has also been licensed to GETmatch for Tier 1 users, and that provides an interactive chart, which then allows users to employ the multiple kit analysis for selected matches. An improved version with better integration from DNA Painter, and as well as AutoTree and AutoPedigree was released last year. So the difference between the regular AutoCluster and the AutoCluster on GETmatch is the fact that you're able to select matches and do something more downstream instead of having just a static picture. For the conclusion of AutoCluster, we've shown that the AutoCluster is able to group DNA matches, and these DNA matches are likely to share a common ancestor. The clustering can be performed automatically for 503 DNA and 23andMe, using CSV files for ancestry or living DNA matches. Last, it's also available for GETmatch for Tier 1 users. Let's continue to the AutoSegment presentation. This is the outline of the second part of the presentation, where we will discuss the AutoSegment. We'll first discuss why clustering using segments can help your genetic genealogy research. Next, I will compare shared match clusters with segment clusters and dive into the concepts of AutoSegment, as well as visualization. We also touch upon some caveats of the tool and show you how you can start the clustering analysis for the different testing companies. The AutoSegment is a DNA-based, segment-based clustering method that is available for locally downloaded files from MyHeritage, 23andMe, Family Tree DNA, and ZMatch. Depending on the input data, it's able to identify triangulating segments or overlapping segments. So in the last scenario, where we find overlapping segments, it is required to perform some follow-up analysis to verify the predictions. So the methodology of clustering DNA matches using segments is not different as compared to clustering using shared matches. This is all based on the idea that you can break your entire DNA match list into groups. And these groups can contain matches that are shared by one or several segments. These segments are a clear indication that you share a common ancestor and therefore a branch of your family. So the analysis of those clusters based on segments is comparable to the analysis of shared match clusters. So interpretation of the trees, contact matches, build quick and ready trees, but also to paint the DNA segments to help classify future DNA matches. That's an interesting follow-up analysis for the AutoSegment tool, is to paint them directly into DNA Painter. It is possible to import them and to have an excellent starting point for your DNA painting efforts. The DNA Painter, as indicated in the previous presentation, generates a chromosome map for your DNA matches, which provides hypotheses for future research. If you've done the research and linked the segment to an ancestral couple, it might help classify future matches. You just check the DNA segment location of a new match and see if it overlaps with a previously characterized segment. Before we continue explaining how the AutoSegment works, it might be good to discuss the irregular clustering based on shared matches. So in this chart, the result is displayed of a regular AutoCluster clustering based on shared matches from family tree DNA. The red cluster represents DNA matches that all match each other. We will now check the shared segments using the chromosome browser on family tree DNA. In this overview, we are seeing the shared DNA segments from the members of the red cluster. As can be seen, only some matches have overlapping segments on chromosome 7 and on chromosome 19. It's good to remember that for shared match clusters, not all cluster members will share the same segment. It's a possibility, but no guarantees. Here's an example of an analysis using MyHeritage segment data. For this analysis, we used DNA matches between 600 and 80 centimorgan and a minimum segment overlap of 18 centimorgan. Let's analyze the third red cluster. As we open the third cluster, we see a chromosome browser that shows where the shared segments are located. In this case, a single well-defined segment on chromosome 13. The segment table provides information concerning the start-end and chromosome information of the segments. Also, a graphical representation of each segment is provided, which clearly shows a good overlap. It's only important to examine the segments using the MyHeritage chromosome browsers to see if the segments are located on the same site. If we enter them into the chromosome browser, we see a rectangle, now indicated in the box, a rectangle that is surrounding the segments, which indicates that the segments are on the same site and are triangulating. Here's a comparison between a regular shared match AutoCluster at the left and an AutoSegment output based on overlapping segments. Again, the AutoCluster DNA matches do not always share the same segments. The AutoSegment DNA matches in a cluster can share one or more segments. Okay, now the concepts. How does the analysis of AutoSegment work? There are different steps involved in this clustering. First, the DNA matches are retrieved from the file that is supplied by the user, after which they are filtered. The first filtering is based on the centimorgan range, so matching sharing more centimorgan as the max centimorgan will be discarded, as are matching that are sharing less than the minimum. Next, the segments are imported for these DNA matches and segments are discarded that are smaller than the minimum segment overlap. So for instance, if you would specify a minimum segment overlap of 9 centimorgan and we would find a segment overlap of 10 centimorgan, we would keep them. So now these are compared, that I was already mentioned before. To calculate the overlap, we employ the human genetic map because that provides the most accurate results. The main chart contains DNA match clusters based on the segment cluster data. So remember when we did the segment clustering, that was very strict because we wanted to have fully connected segment clusters, meaning that every cluster, every segment in the cluster should overlap with the other segments. So that makes sense, of course, in the light of triangulation, but for the DNA match clustering, that's not really necessary. So the clustering isn't as strict as the segment clustering. What we have noticed is that fully connected clusters, but not always, represent a single shared segment, like the ones that are now indicated. And the not fully connected clusters usually represent multiple shared segments. And in quite a few cases, the HTML chart of the auto segment analysis will be too large. But luckily, an Excel file is created for every analysis that allows you to examine the clusters in Excel. The cluster colors are represented in the first column. The second segment cluster sheet, which is then available in the same Excel file, is inspired by the segmentology blog from Jim. And that shows the different segment clusters in a Excel wave format as well, ordered by their chromosome position. One of the things we also noticed after obtaining diverse results were some giant clusters containing pile-up segments. So these segments are sometimes quite prevalent, and it can be difficult to find a common ancestor with the match, as already discussed in the previous presentation. It's quite easy to spot those pile-up clusters. In this case, it's a fully connected cluster consisting of 95 segments. If you look at that segment cluster more detailed, all of these were on chromosome 15. Also note that the start position is quite similar for all of those segments. A study from Lee et al. From 2014 has identified some of these pile-up regions, and the pile-up region that we just discussed in one of those regions is on chromosome 15. There's an option for AutoSegment to ignore all segments that are overlapping with a known pile-up region, and then all of those gigantic clusters will be discarded. Still, it is possible to see some pile-up regions. These are then your personal pile-ups. There's a visualization of these pile-ups for the analysis, so that it allows you to quickly spot those regions on your genome. So there's a chart created for every chromosome from the analysis. Well, it's good to stress the main caveat of the AutoSegment tool. So since we're using flat segment files, it is not possible to infer triangulation. We can only see that segments are overlapping, but they can easily be on different sides, so one paternal or one maternal. So it's very crucial that you check these segments on the underlying website. The exception is JetMatch, since we are using the triangulation files from their site. Well, as some of you might already guess, the segment datasets are quite universal, so exchangeable between the different companies, except for ancestry. So we decided to make a new clustering approach based on the AutoSegment called Hybrid AutoSegment, which uses the same principles as AutoSegment, but are now used for the Hybrid AutoSegment, which allows you to cluster the segments from different companies. In the example cluster, we see matches from all different companies in one cluster. The segment cluster table for this analysis is quite similar to the one before, but with the exception that it now provides the DNA testing company column with information for each DNA match. It's also interesting to note there's a gigantic segment cluster table underneath the main chart in the main HTML, which contains every segment cluster. This allows you to find back DNA matches that are not in the chart, so not linked in the chart, but are still having a segment in the segment cluster. One variation of the AutoSegment tool is the automated AutoSegment for family tree DNA data. This version of AutoSegment is called AutoSegment in common with, and it employs shared match data to validate overlapping segments. So overlapping segments are only kept if the underlying DNA match is a shared match of each other. If they're not, they are discarded. Of course, this greatly improves the quality of the triangulation groups. The same variant is also available for 23andMe, but instead of using shared match data, we employ the DNA overlap information that is provided by 23andMe. So overlapping segments that are linked to a DNA match are kept and are used for the segment clusters. Interestingly, so this particular feature has been updated, not visibly for users, but for other people like me and folks that are doing some automated analysis. And this is now more precise as before. It used to only tell people that the DNA, that there is something triangulating, but now it also tells you where specifically a segment is triangulating with a specific match. Now for the conclusion, we have shown that the AutoSegment is able to group DNA matches based on shared matches. These matches are likely to have a common ancestor. The clustering can be done automatically for family tree DNA and 23andMe, and using local segment files for family tree DNA, 23andMe, MyHeritage, and JetMatch. And since last year, the AutoSegment tool is also available for Tier 1 users on JetMatch. It provides the same look and feel as the analysis on Genetic Affairs, but it has some additional features like the ability to select the segments from a single chromosome and to play around with the minimum SNP levels. All right, so this concludes the AutoSegment. We will now continue with the Auto tree. This is the outline. We will first go to the concepts, visualization, and how it identifies common ancestors. This tool works primarily for autosomal DNA matches, but there's an option to work with Y-DNA and mitochondrial DNA matches as well. And in the last start, we'll be showing how to start the analysis. So the auto tree uses a tree shared by DNA matches to find common ancestors. And using those common ancestors and their descendants, it can then reconstruct a tree. It works with genealogical trees from your DNA matches, as well as the tree that is associated with the tested person. Available on Genetic Affairs for Family Tree DNA and on GEDmatch for Tier 1 users. So from a previous presentation, we explained the AutoClusters. I think this is the third time I've shown this slide already, but this is the basis of the auto tree analysis. We discussed that members of clusters are likely to share the same common ancestor. So it makes sense to only take into consideration the matches from a single cluster and then to look in the trees to find the common ancestors. So the methodology of AutoTree is therefore based on the trees of the members of these clusters. Having a reconstructed tree can help you identify the common ancestors of the remaining DNA matches in that particular cluster. It also works without the need of having a tree of yourself. So it also works for adoptees or donor-conceived persons. Here is a short on how the AutoTree works. It analyzes the trees of matches and then identifies common ancestors. First, we perform a surname clustering based on all the tree persons from the trees of your DNA matches from a single cluster. Next, we perform a first name clustering. And last, we perform a birth death year clustering. We then reconstruct the trees and visualize these for the common ancestors. In this visualization, you see the common ancestors. At the right side of every tree branch, the DNA matches are displayed. These are also visualized using a color gradient to spot the high centimorgan matches more easily. The tree persons linked to the profile that's analyzed can also be integrated. So if you've linked your own tree to the Family Tree DNA website or GEDmatch, you will see yourself as well. It's not needed. If it's available, the tested person is displayed in green. Another thing that's being calculated by AutoTree are common birth locations. This procedure can link certain ancestors for DNA matches and provide clues where a specific link can be expected. The common ancestors are also integrated in the main AutoCluster chart using the Christmas trees, and also integrated in the overlay information. And also a GEDcommits file is created, which will allow users to import a reconstructed tree, for instance, in Ancestry or other website. If you have a tree available for your tested profile, there's also an overview created that will show how many DNA matches are linked to each of your direct ancestors. So this is like the true lines or the theory of family or MyHeritage. This initial overview will only show a couple of generations, but you can also view more generations. If there are DNA matches linked, you can see the clusters where they originated from. And if you click on the link, you will see a reconstructed auto tree of those matches and your shared common ancestor. A new addition to the AutoTree family is the ability to analyze shared common ancestors in trees of Y-DNA or mitochondrial DNA matches. In addition, trees from autosomal matches are also added to the analysis. If you're lucky, you will obtain a common ancestor with a Y-DNA match in your autosomal match as well. This is mainly interesting, this analysis, if you're having a lot of Y-DNA or mitochondrial DNA matches and you're not willing to spend a lot of time looking for common ancestors. To improve the identification, we have now also added the blue and pink visualizations to see if the line is completely pink or completely blue. This is how you start the AutoTree analysis. So this is only available for Family Tree DNA profiles. First, we select the Family Tree DNA profile of interest. We select the AutoTree option. You set the minimum and maximum parameters and you start the analysis. And results are then obtained by email or can be downloaded from our site. Now we will discuss more or less the last part of the presentation, which is the auto kinship tool. So as in the previous presentations, we will discuss the concepts, the visualization, and the implementation for 23andMe, followed by the auto kinship for MyHeritage. Well, the principle behind the AutoCluster is that it organizes your, well, this is, I think, the fourth time I'm already telling this, the match clustering that represent the branches of your family. But the thing is, if you have the AutoCluster, you are not always sure how the generational levels of the matches underlying this cluster, how are they related? So in essence, the AutoCluster represents only a limited perspective regarding how matches are related. It's like a flattened perspective. So we know that they are likely to share common ancestors, but how is everybody related to each other? Are there different common ancestors? Is there a central common ancestor, or are there some variations within the cluster? The auto kinship is performed using the members of clusters obtained from an AutoCluster analysis, which is all then based on DNA and is able to then reconstruct a tree. So using the shared DNA between the matches in a cluster, as well as the amount of DNA you share with them, auto kinship reconstructs and compares many different trees. So having these trees provides hypothesis how matches might be related to each other. Usually the top 10 trees are reported. There are some 3 options available, but since it only employs shared DNA information, it also works for adoptees or donor-conceived persons. It works for all companies to provide the shared DNA information between shared matches. At this moment, only MyHeritage, 23andMe, and GEDmatch are supported. Here's an example of auto kinship. Here we have a reconstructed auto kinship tree performed for my great aunt Mia. Liam and Olivia share more than 2,900 centimorgans and are predicted siblings. They share on average roughly 1,600 centimorgans with Aunt Mia. And one of the relationship options is a niece-nephew relationship. Eva and Charlotte share 3,452 centimorgans, so an obvious parent-child relationship. But who is the child? Aunt Mia shares almost 400 centimorgans with Eva and 110 centimorgans with Charlotte. Eva is therefore most likely the parent, placed as a first cousin once removed in this chart. Last, Aunt Mia and Emma share a considerable 435 centimorgans, which could very well be a potential first cousin once removed. Still, a second cousin is also an option. Emma and Eva share almost 1,100 centimorgans, which most likely makes them first cousins. The first cousin prediction of Emma and Eva fits nicely with the first cousin once removed prediction of Emma and Aunt Mia. So, as was shown in the previous example, by examining many possible relationships, it is possible to reconstruct many trees using only the shared DNA information between DNA matches. It is similar to Wado, but Wado only looks from the perspective of the tested person, which is why it also works for ancestry data. And the generated trees created by auto kinship are sorted based on their combined probabilities, making it easy to first scan the most compatible trees. Also, which is noteworthy, the probabilities are used by our approach are all based on simulations specifically done for its testing company created by Britt Nicholson. And here's a very nice website with lots of interesting tools and blog posts, which is now displayed on the chart on the screen. The auto kinship tool is available for 23andMe profiles. So to get the reconstructed tree for 23andMe, first select the profile of interest, select the auto kinship option, select the min-max, and start the analysis. And as seen before, the results are emailed or can be downloaded from our site. This is all done automatically, which is quite nice. This is just one option that you enable, and everything is done automatically. For MyHeritage, it's still possible to do the analysis, but it's quite some more work as compared to the 23andMe analysis. So to perform the analysis on MyHeritage, we need to supply auto kinship with 2 CSV files. One file with the match information and one file with the shared matches. First, we need to obtain the information about our matches. So we need the match name, the shared match, and the generation column, which is optional. Second, we also need to provide the information about the shared matches. This normally for cluster requires 2 columns, but now we need 3 columns. So the match name, the shared match name, and also the amount of shared DNA between shared matches. Getting the data, like I said, is quite some work for MyHeritage, although we did make some tools to make life a little bit easier. To do this, first run the AutoCluster tools on MyHeritage, save the report and unzip the zip file from the email, examine the report and select the cluster of interest, then go to our website and upload the HTML file to our site. And after a few seconds, you will get a file that represents the Excel spreadsheet with all of the matches and shared match information. And this also contains information per cluster. So this is the basis of your analysis. This is the starting point. Next, we need to obtain how much DNA our shared matches share. So for each match, there are a number of shared matches. This is the amount of DNA I am sharing with the shared match. This is the amount of DNA my match is sharing with each shared DNA match. This particular information is going to be copied into Excel. For each match and shared match combination, find back how much DNA they share, fill it in the last column, and as you can expect, which is quite time consuming. Next, you visit our site again. You go to the manual auto kinship page. We use the bulk import to paste the matches from our cluster of interest, and we'll do a bulk import of the shared matches of that cluster. If the generational information is available for the tested person, we can set it. We can provide a name for the analysis, like the sort of the centimorgan probabilities, and start the analysis. In some cases, part of the predicted trees, predicted tree is already known. So for instance, if you have done some research already. So ideally, one would like to use the known tree as a basis for the auto kinship predictions. It is possible to create a known tree in Wardo, save it, and load the saved Wardo tree into auto kinship. For instance, the hybrid analysis that I am showing here in gray, let's zoom in a little bit. In gray are the ones that are already known from previous analysis. And in red, you see the parts that have been added by the auto kinship tool. And now for the final part of the presentation, and also the most exciting part. We are currently putting our last dots and I's on the for the auto kinship implementation for JetMatch, which is then available for tier 1 users. And I've actually combined all of the tools that are present on JetMatch from our site in this analysis. So it combines AutoCluster, AutoTree, AutoSegment, and the new auto kinship tool. Underneath the animated chart, there's a section nowadays available that explains every step. If you click on a tool, then you get a short description how the tool is working. We now provide an overview table that contains clickable icons to each of the individual tools. So the result of the auto kinship report table has the links to the different analysis. So first, the cluster name for which the results have been found. It's the first column. Then we have the AutoTree results, the common ancestors by AutoTree, the common locations found by AutoTree, the auto kinship trees, the auto kinship trees with AutoTree integration. We'll discuss this new feature in more detail in upcoming slides. AutoSegment, and the common surnames found by AutoTree. So let's now examine the predicted auto kinship that was created by the auto kinship implementation on JetMatch. If you look at this tree, and this is actually based on the excellent data set from Tim Janssen, who has allowed me to use this data. We see some very high centimorgan matches for the tested person. We can actually identify 4 siblings as well as their first cousin in this particular chart. And if you click on a match, so this is all, you see the amount of shared centimorgans per match. But if you click on a match, you will notice a pop-up text. And this pop-up text also contains the sorted shared centimorgans predicted relationship, the probability with all of the other matches from the perspective of that click match. So typically, from the previous slides, you see the centimorgan information from the perspective of the tested person, so in green. But of course, the matches themselves have different centimorgans information with the other matches. So this is the information from the perspective of the match. And in addition to having the shared DNA information between DNA matches, we also use the fully identical region centimorgan information to improve the predictions between half and full siblings. So full siblings would share a considerable amount of fully identical region DNA, whereas half siblings will not. The result of the AutoTree analysis can be accessed by clicking on the icon in the table. And you will see then the results of the previous chart. So let's examine the AutoTree result for this cluster. We see the same siblings as well as their first cousin, which is then a second cousin from the perspective of the tested person. Would think, well, I have this interesting AutoTree information. Why not combine this with the auto kinship, like with the Wardo trees? This would then result in a hybrid analysis with the predicted tree based on a genealogical tree and a tree based on shared DNA. This is a new feature. And so in addition to making the interpretation much easier, it will also sometimes improve the quality of the reconstructed trees. And this is accomplished because the possible relationship based on the shared DNA can then be restricted by the AutoTree predictions. For instance, if we have a 200 centimorgan match, which has the highest probability of being a second cousin. But if the AutoTree provides evidence of a third cousin relationship, this relationship, which has a lower probability, will then be used for the AutoTree predictions as well. So you're basically forcing the auto kinship to only implement evidence from genealogical trees if available. And this is the output of the newly developed feature, which combines the auto kinship predictions with AutoTree informations. So first the siblings, their first cousin, and the tested person. And as can be seen in the newly constructed tree, all of the common ancestors from the auto tree are now integrated in the analysis. So this is like a hybrid tree based on genealogical information as well as predicted tree branches based solely on DNA information, having best of both worlds. Another feature that has been integrated into the auto kinship tool are the shared segments as identified by AutoSegment. And as is the case with AutoTree, the AutoSegment information is also available as a separate analysis, and this provides the shared segment information for the matches from an AutoCluster analysis. And you can access it by clicking on the icon in the table overview. And this is the output. The shared segments are also integrated in the auto kinship charts and are represented using the different colored badges indicated now. So let's examine some of those in more detail. So the colored segment cluster badges are clearer in this visualization, and the number that you're seeing in each of those badges represents the chromosome. If you click on the pop-up text, you will see more information concerning the individual segments from this particular segment cluster. So the nice thing about this segments badges is that you can really follow the segments that are linked to matches from in your cluster. So if you go to this particular match, which is the parent of the match next to it, you can see that the same segments have been inherited by the child. And these examples are quite interesting. So you can really follow the inheritance path of different segments of this particular cluster, which can be quite interesting. This is a mock-up of the upcoming auto kinship interface. I think all of those tools will become available on the new interface of JetMatch. I think JetMatch really wants to push us to the new interface, and I think always the implementation for the classic side is always lagging. It will require the kit number, the lower and the upper centimorgan threshold, and some of these auto segment related parameters. And as with the auto segment results of JetMatch, results for the auto kinship tools are provided as a zip file that needs to be unpacked on your computer. After downloading and unpacking the zip file, you can open the main HTML to open the results. So this is all work in progress. I hope to release this. We hope to release this feature in the upcoming weeks. Stay tuned. Okay, this is the final conclusion of the auto kinship and auto tree tool. So we've shown that the auto tree is able to reconstruct the trees based on trees shared by DNA matches. The auto tree integration for auto kinship combines best of both worlds. You are able to integrate the trees in the reconstructed trees based on DNA, which is a feature created for JetMatch. The auto segment provides shared segments for the auto kinship branches. The auto kinship tool reconstructed trees based on the shared DNA between shared matches, automatically for 23andMe matches, semi-automatically for MyHeritage, and it will be available for JetMatch Tier 1 users. This is my last slide, some additional resources. First, we have a very helpful Facebook group that helps out with all clustering-related questions. And we have 2 blogs that stand out with the coverage of genetic affairs. The one from Patricia Coleman usually has the latest tools, and the DNA Explained from Roberta also describes quite a few of our tools as well.